Well, this is computer science, of course. First of all, there's the trivial multiprocess model, which goes back to the 70s, if not before, the batch queue. If your machine has more than one processor in it, it's simple to set up a batch queue. You submit your job to the batch queue. It puts it on as many systems as are running, puts it on as many processors as are available. Those jobs run concurrently. They finish. Job is done. This is very easy to implement. It requires no real change in your code. Obviously, it can't be done with code that makes use of a GUI because once it's in a batch queue, there's no user interface. A more robust multiprocess model is what referred to in another question, which is the multiprocess, which is the message passing model, wherein you have a single process that probably fires off multiple processes which work together to solve a single problem, and they pass messages back and forth. This is not a very efficient use of system resources. It requires a fair amount of upfront coding, but it may actually be more scalable in the long term, and it's certainly much easier to debug and maintain in the long term than some other methods. And then, although there are probably others, there's also the multi-threaded model. It's quite efficient in the use of system resources because only one process hosting however many parallel threads of execution are occurring. It does require considerable code changes. It's quite invasive code changes. And all components that are used need to be thread safe. I'll explain that a bit later, what thread safety is all about. Also, multi-threaded programs are very difficult to debug, get performing well, and maintain. But if you do a good job at it, and/or your problem is easily decomposed into a parallel operation, it can give you excellent performance and is pretty much the model we would like you to at least start thinking about, because the other models are a little harder to work on.